Well, hi there, boys and girls. Today we're going to take a look at some sine and cosine graphs, and we're going to try and come up with some shortcuts. So let's go ahead and get started. Let's call this y equals sine x and y equals cosine x. I want you to know what the basic graph for y equals sine x and y equals cosine x look like. So let's just get started here. Okay, for sine of x, there are some important things to know. First of all, the amplitude, I'm just going to call that A, is 1. And the period is 360 degrees. So if you were to graph one graph of sine, we would start at 0 and go all the way out to 360 degrees. And then we would put a dot halfway between that, which would be 180, and then halfway between that, 90, and then halfway between 180 and 360 and 270. And these are these important critical points, 0, 90, 180, 270, and 360. Sine has an amplitude of 1, which means it's going to go up to 1 and down to negative 1, and it goes through the middle. And so we can just put a dot there, 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 here, and here. We can connect the dots. And this is our basic sine graph. Sorry about the little hiccup right there. That didn't work very well. All right, now for cosine x. All right, for cosine x, we still have an amplitude of 1, and we have a period of 360. So we do 0, 90, 180, 270, 360. Okay, and then the cosine starts at a peak. Starts up here because the cosine of 0 is 1, cosine of 90 is 0, cosine of 180 is negative 1. And so here's the basic graph for cosine. We should have figured that out yesterday, but anyway, I just want to make sure we have those basic ones. I'm going to throw in some more terminology. The middle of the graph, the horizontal middle of the graph, this is called the sinusoidal axis. Sinusoidal axis, the middle of the graph. All right, so let's just go forward and graph a couple of things. Let's do 3 plus sine of x. All right, now if you should know from your transformations that any time you add or subtract to a function, all that does is it moves it up or down. So what this is going to do, the 3 plus is going to affect the sinusoidal axis. It's just going to move it up 3. So this means up 3. So what I'm going to do is instead of having a sinusoidal axis here on the x-axis, I'm going to draw it up here at 3, and I'm going to do a little dotted line here to represent the 3 plus. Now I haven't affected the period at all, nor have I affected the amplitude, because I didn't multiply in front by anything, or did I put a coefficient on the x either. So my amplitude is still 1, and my period is still 360 degrees. So I'm still going to have on the x-axis 90, 180, 270, and 360. I'll just label a couple of those. My amplitude is still 1, but my amplitude is how far we go up or down from the sinusoidal axis. Now sine usually starts at the middle and then goes up and then down and then back up. So now this just means our new middle is 3. And so at 0, I'm going to be up here at 3. Then I'll go up 1 to 4. Why did I go up 1? Because the amplitude is 1. Back to the middle of the sinusoidal axis. Down 1, which would be down to 2, and then back up to the middle. I still have the basic sine graph, but it's just been shifted up 1. I'm sorry, up 3. Our amplitude is 1, up and down 1. So that's 3 plus sine of x. All right, let's do another one. Let's graph 2 minus cosine x. And I want you to think about this as 2 plus negative cosine x. All right, so let's see what happens here. All right, so we have the 2 minus or the 2 plus negative cosine x. This is a vertical shift. This means up 2. Now what does a negative do? A negative to a graph reflects it across its sinusoidal axis. So I'll show you what that means here. Let's go ahead and graph this. We're going to, instead of being a sinusoidal axis along the x-axis. I'm going to go up here to 2, and I'll put little dots. And we have not affected the amplitude or the period. We did put a negative in front of the cosine x, but I didn't put a number there other than 1. So we're still going to be going up 1 and down 1 from there. I'm still going to have a period of 360 degrees. And I've got my 270 and 90 there. Now, instead of starting at the top, since we got reflected across the axis, like cosine x starts at the top, we're going to start at the bottom. Then go to the middle, then to the top, back to the middle, back to the bottom. And so there's a graph of 2 minus cosine x. All right, let's do one more example. Let's graph negative sine of 2x. I should put a y equals there. Let's graph y equals negative sine of 2x, and let's do it without doing the chart like we did yesterday. Okay, I want you to remember from our notes that the period is equal to 360 degrees divided by the number that we put in front of x, or divided by b is what I put in the notes, which is going to work out to be 180 degrees. So now we're going to affect what we put on the x-axis. So I'm going to go start at 0, and I'm going to end at 180. I'm still going to mark off halfway 90, halfway 45, and halfway 135. Those are my critical points. Now, sine usually starts in the middle, then goes up and back down, and then back up. But since it's negative, it's going to be reflected. So here's how we're going to graph this. We did not affect the amplitude. The amplitude is still 1, but instead of going up and then back down, I'm going to go down and back up. So let's see if we can label these. That's a negative 1. And there's a positive 1 back down here. So here is a negative sine of 2x. All of this we did without doing all that chart stuff because we know our basic sine and cosine. So you're going to be practicing this tomorrow in class, and I will see you guys then.